Good morning, all of you. Welcome to MLC Foundation. So today we will discuss a question that is proof that root 2 is an irrational number. Root 2 is an irrational. Prove that root 2 is an irrational number. This is an important question for class 9th and 10th also. Okay, so let's see how to prove root 2 is an irrational number. So before we have to prove root 2 is an irrational number, we have to know two number system. That means one is rational number, another is irrational number. So what is rational number? The number which can be expressed in the form of p by q, where the q is not equal to 0, is known as rational number. Similarly, irrational number is opposite to the rational number. The number which can't be expressed in the form of p by q, where q is not equal to 0, is called an irrational number. The number which is expressed in the form of p by q is known as a rational number, and the number which cannot be expressed in the form of p by q is known as irrational number. Where p and q are co-prime. Where p and q are co-prime. So what is the meaning of co-prime? Co-prime means p and q have the common factor only one. P and q have the common factor only one. That means common factor of p and q are only one. That means SCF of PQ also one. SCF of PQ is equal to 1. That means co-prime is that two number is co-prime. We set to co-prime two number, then when the SCF of P and Q is equal to 1, that means common factor of P and Q is only 1. So let us prove that root 2 is an irrational number. So root 2 is an irrational number is proved by the method of contradiction. Root 2 is an irrational number is proved by the method of contradiction. Method of contradiction. So what is method of contradiction? Method of contradiction is a process in which we assume a statement that contradicts our assumption. We assume a statement that contradicts our assumption. That contradicts our statement. We assume a statement that contradicts our statement. That means our statement is given that root 2 is an irrational number. So we assume a statement which contradicts. That means we assume that root 2 is an rational number. Clear? The method of contradiction is that process. So let us see. So first of all, proof. So let's assume that root 2 is a rational number. Root 2 is a rational number. Why we assume root 2 is a rational number? Because we have to prove by using the method of contradiction. So we have to assume that root 2 is a rational number. Clear? If root 2 is a rational number, then root 2 can be expressed in the form of p by q, where q is not equal to 0. The number which can be expressed in the form of p by q is known as rational number. That means every rational number can be expressed in the form of p by q. And here root 2 is a rational number, so root 2 also can be expressed in the form of p by q, where q is not equal to 0. Then by cross multiplication, p is equal to root q. By cross multiplication, p is equal to root q. Then by squaring both sides, p square is equal to root 2 whole square. Squaring both sides, p square equal to root q whole square. That implies p square equal to 2q square. P square equal to 2q square. Let's see the statement. If I multiply q square with 2, then we get p square. If we multiply q square with 2, then we get p square. Similarly, if we multiply 5 with 2, we get 10. We multiply 4 with 2, we get 8. So 2 divides 10, 2 divides 8. Similarly, here we multiply 2 with q square. That means the result is p square. If we multiply 2 with q square, the result is p square. That means 2 divides p square. Clear? 2 into 5 is equal to 10, that means 2 divides 10. 2 into 4 is equal to 8, that means 2 divides 8. 2 into q square equal to p square, that means 2 divides p square. That implies 2 divides p square. Clear? 2 divides p square. Then if a prime p, there is a theorem, if a prime p divides a square, then the same prime p also divides p, yeah, a. If a prime p divides a square, this is the symbol of divides, then the same prime p also divides a. That means if 2 is a prime, 2 divides 64, 2 divides 64, that implies 2 divides also 8. Clear? Similarly, if 2 divides p square, then also 2 divides p. Clear? 2 divides p square, then 2 divides p. So if 2 divides p, then I can write p is equal to 2 into something r. I can write, reverse the statement. If I multiply with 2 with something, then the result is p square. If I multiply q square with 2, then the result is p square, that means 2 divides p square. Similarly, if I multiply 2 with r, then the result is p, then 2 divides p. Similar statement, but change the order, or reverse the statement. So now set squaring both side. Now squaring both side. By squaring both side, p square is equal to 2r square. P square equal to 2r square. That implies p square is equal to 4r square. P square equal to 4r square. Put the value of p square from here. That is equal to 2q square from here. That means 2q square is equal to 4r square. 2q square is equal to 4r square. So by cancelling 2, we have q square equal to 2r square. Similar statement. If I multiply 2 with r square, then the result is q square. If I multiply 2 with r square, then the result is q square. That means 2 divides q square. If 2 divides q square, then 2 also divides q. Clear? Here 2 divides p and here 2 divides q. So let us assume two statement. 2 divides p and 2 divides q. So from here, from plus equation 1 and equation 2. From equation 1 and 2, from equation I and double I, 2 divides p, 2 divides q. That means 2 is a common factor of p and q. 2 also divides p, 2 also divides q. That means 2 is a common factor of p and q. From I and double I, 2 is a common factor of p and q. But we know that if a rational number can be expressed in the p by q form where p and q are co-prime, that means the only common factor of p and q is 1. But here from I and double I, we found that 2 is a common factor of p and q. But we know that only 1 is the common factor of p and q. But we know that p, q are co-prime. That means only 1 is the common factor of p and q. But we know that p and q are co-prime. But we know that p and q are co-prime. That means only 1 is the common factor of p and q. But here 2 is a common factor of p and q, which contradicts our assumption. Which contradicts our assumption. That means if we don't assume that root 2 is a rational, then we don't reach a contradiction. That means p and q are not co-prime. If we not assume that root 2 is a rational, then we can't find that 2 is a common factor of p and q. So our assumption statement is also wrong. We assume wrong, so we reach a statement which is universally false. That means p and q are co-prime. So which is contradicts our assumption. That means the statement 2 is a common factor of p and q is contradiction. That means the 2 is not a common factor of p and q. Only 1 is the common factor of p and q. This is a false statement. So our assumption is wrong. So our assumption is wrong, which is contradicts our assumption. Therefore, root 2 is an irrational. Root 2 is an irrational number. Root 2 is an irrational number. Clear? So this is an important question for class 9th and 10th students also. So similarly, in the similar process, in the similar by method of contradiction, you can also prove that root 3 is an irrational number. Here root 3 is expressed in the p by q. Here p is equal to root 3 q by squaring both sides. Similarly, 3 is a common factor of p and q. 3 is you can find 3 is a common factor of p and q, which is also a contradiction. Similarly, root 5, you can prove root 5, root 7, root 10 also irrational. Here you can find that 5 is a common factor in root 5, 7 is a common factor in root 7, 10 is a common factor in root 10, which is also a contradiction. So now try the questions root 2, root 3, root 5, root 7 and root 10. Try to prove that root 2, root 3, root 5, root 7, root 10 are irrational numbers. If you have any doubt, then let me in the comment box. Thank you.